Welcome to The Explainer. Today, we're unpacking what is honestly an absolute breakthrough in decentralized identity. We are looking at exactly how a new standard called ERC-7827 orchestrates global physical agents. And just to set the stage here, we're going way beyond the basic smart contracts you're probably used to. We are looking directly at the foundational architecture of digital sovereignty itself. So to kick things off, I want you to think about this fascinating question. How do you fit an entire sovereign identity into a microscopic 32-byte digital space? This right here sits at the very heart of what developers call the namespace paradox in Web3. How do you create an identity that is mathematically flawless, globally recognized, and yet lightweight enough to operate on the absolute base layer of a blockchain? To figure that out, here is our roadmap for today. We'll start with the namespace paradox, move to the sovereign identity model, decode the LNA33X bit packing and its 3.3.26 partition, explore semantic containment, and finally, look at liquidating informational debt. All right, Section 1, the namespace paradox, bridging human readable identity and structural authority. Now, you really see this paradox when you contrast the two heavyweights of on-chain organization. On one side, we have the Ethereum Name Service, or ENS. It's a mapped namespace, right? It gives you a great human-readable name like alice.eth, but the catch is that the name itself has no inherent technical authority. It actually requires an external registry and a resolver to map that name to a machine state. On the other side, we have HATS protocol. HATS provides this incredible structural authority, acting as an on-chain organizational graph where roles are tokens in a hierarchy. But it's non-symbolic. The identities are these complex numerical bitmaps, not human-readable text. So the paradox is, historically, you've always had to choose between legibility and built-in authority.
Moving right along to Section 2, the sovereign identity model, the Liechtenstein Principality analogy.
To solve this paradox, think about the Principality of Liechtenstein for a second. Historically, the Prince of Liechtenstein wasn't out there seeking to conquer massive neighboring empires. Instead, his sovereignty was strictly anchored to a very specific, compact territory. Well, in the digital realm, a sovereign digital identity has to operate the exact same way. It needs to be strictly bounded. It's a non-expansionist approach. Your authority is absolute, but it's completely confined to a highly specific, strictly defined digital border.
And this is exactly where ERC-7827 comes into play. It takes this whole non-expansionist philosophy and turns it into a verifiable legal wrapper for real-world entities. Basically, it acts as a JSON smart contract, meaning it flawlessly tracks every single state transition directly on the blockchain, while ensuring that the data stays entirely human-readable and accessible via standard web requests. It gives that digital sovereignty a permanent tamper-proof record. Which brings us to Section 3, decoding LNA33X bit packing, magnifying the microscopic foundation. LNA33X is really the technical heartbeat of ERC-7727. It's this absolutely ingenious bit packing codec, basically a way of tightly cramming information together so that it natively supports ENS namespaces while simultaneously adding structural authority right at the base layer. It's honestly an engineering marvel. It achieves absolute precision without wasting a single bit.
And when I say microscopic, I mean it. Every single on-chain agent's container, its core identifier, is exactly 32 bytes long. That's it. It's a single EVM word. In the Ethereum virtual machine, 32 bytes is just the standard unit of data. So this tiny, incredibly limited space serves as the strict clinical border of that digital sovereignty we were just talking about.
Let's crack that open in Section 4, the 3.3.26 partition, the clinical integer geometry.
When we actually break down this 32-byte container, a very specific mathematical partition emerges. It's sliced into a precise ratio of 3 to 3 to 26. And this isn't random at all. It's a highly deliberate integer geometry, specifically designed to absolutely maximize data density within one single operation on the blockchain. Ultimately, it serves as the foundational building block for a self-mapping namespace. Let's really unpack that payload, because this is where the magic happens. First, you've got 3 bytes acting as a link. These point backward to allow for long string concatenation, meaning you can chain them together to build complex ENS handles without ever hitting those strict data limits. Next up, the 3-byte knots. This is just an incrementing number, but it guarantees that this specific state is final and chronologically sound. And finally, the remaining 26 bytes hold ASCII text. This is the actual human-readable payload storing the agent's name. By packing a cryptographic link, a state-verifying nonce, and a 26-byte human-readable payload into one single 32-byte space, we completely bypass the need to scan massive, expensive transaction histories. The identity and its authority are instantly verifiable.
All right, Section 5, Semantic Containment and Island Hats, fusing global reach with granular control.
This clever bit packing trick brings us to a concept called semantic containment. Within this ecosystem, there is an implementation known as island hats. Now, instead of needing really complex manual links between roles like you'd see in traditional protocols, island hats simply looks at those 26 bytes of ASCII text. By scanning the prefixes of the text itself, the protocol dynamically figures out who has authority over what. If you own the parent namespace token, you automatically possess the authority to act on or create subagents. The name itself becomes the permission, which creates this incredibly elegant self-mapping namespace.
Now, these distinct shards we've been talking about, they all stack together to create a legally binding, what they call atomic pulse for an organization. This is the SIS-01 identity trinity. First up, the mind pipe uses the ERC-7827 standard to act as your root signature and your global ENS name. Next, the unified body uses ERC-1155 for the island hats we just discussed, and that handles your functional roles. Finally, the individual cell represents the specific unique coordinate of a physical agent operating on your behalf. So you have 3 layers, completely backward compatible, all speaking that exact same 32-byte language.
And finally, Section 6, Liquidating Informational Debt, from cloud approximations to bare metal truth.
Now, zooming out a bit, this represents a massive philosophical shift. Traditional cloud computing and AI often rely on a probabilistic model, what the authors brilliantly call a smoothie of approximations. But ERC-7827 demands the ALU-Surveyor approach. Every single action is a deterministic, bit-perfect record of human intent. There's no guessing involved anymore. There's only verifiable truth.
Because this bit-perfect integer geometry is so incredibly dense and precise, it allows smart contracts to operate actual, physical, real-world hardware safely and instantly. Literally, a token transfer on the blockchain can trickle down to a device like a cheerbot, triggering electrical GPIO pins to move a motor or flip a switch with O1 complexity. That means it happens directly, bare metal, without complex computational overhead. AI agents suddenly stop being these unpredictable, autonomous wildcards and instead become strict, deterministic scripters of your exact intent.
Well, that brings us to the end of today's explainer. We've seen exactly how packing a 3-byte link, a 3-byte nonce, and a 26-byte human-readable payload into one single microscopic 32-byte EVM word fully solves the namespace paradox, creates a symbolic self-mapping namespace, and flawlessly bridges the digital and physical divide. So I want to leave you with this one thought. If a 32-byte digital token can deterministically command real-world hardware, what happens when our entire global physical infrastructure is operated by self-mapping, sovereign smart contracts? It's pretty wild to think about. Thank you so much for hanging out, and until next time, keep learning.